and hello. And today we're going to talk about using inverse. And we are going to work with all four operations, which is your addition, subtraction, multiplication, division, and we're going to talk about our friends, the equal signs, which means the same. So these are all the problems we're going to look at today. We're going to use all four operations and we're going to use inverse. And hello. Today we're going to be talking about inverse. It's the word that you've definitely heard, and some of you might think, oh, I know what inverse is. And some of you, I'd imagine, are already quite comfortable with using inverse, a very important concept, a very important idea in maths. And so today we're going to practice using inverse. And this week it will be our goal to apply inverse to all four operations. So our four operations is addition, putting two groups together, subtraction, removing a group, multiplication, counting in equal groups, division, sharing into equal groups. And the equal sign tells us that the two sides of an equation are the same. So let's have a look at the beginning. So first we're going to start with the operation we know the best, addition. Addition means putting two groups together. And using inverse means working in reverse. So normally our addition problem would look something like 2 add on 3 equals 5. So I had 2 apples, I got 3 apples more, and all together I ended up with 5. Yeah, this is 1, 2, 3, 4, 5 in a group. Now, when it comes to inverse, it's the missing box problem. It's when we know the ending. So let's say we have the ending of the number that you're very familiar with, 100. And we know the beginning of the problem, which is 25. So let's say that I had 25 pounds, then I won some more in the lottery, and I ended up with 100 pounds. What is the missing part? Because that's what inverse is working in reverse, is finding the missing part. So what I would have to do is I would have to remove the part I know to give me the missing part. If I imagine that as a bar model, I had a total of 100 and I had a part of 25, and that's my missing part. So if I cut off the part of 25, that will be the remaining. So if I want to use inverse, what I would have to do is I would have to subtract 25 from 100 in order to find that missing part. So I would go 100, take away 25, and let's go quickly. I can't subtract 5 from a 0. I can't subtract 5 from a 0. So I would have to exchange, but I can't exchange because there's a 1. So I will exchange that from a 1. That gives me 10. Now I can turn it into a 9. That gives me 10. 10 take away 5 gives me 5. Now I have 9 left over here. 9 take away 2 gives me 75. 75 is my missing part. So that's inverse. And I know you know that. You're doing the opposite operation. Let's try it one more time. Feel free to pause the video and practice independently. So let's say that we have 48, then I've added something and I've ended up with 72. Now pause the video and I shall wait. While I'm waiting, I'm going to prepare and I will have to subtract. So 72 take away 48. So I will subtract the part I know from the total. So now I can take away 8 from 2. Now I have to exchange. So that gives me 12. That turns into 6 tenths. 12 take away 8 gives me 5. 6 tenths take away 4 tenths gives me 2 tenths. So now I found the missing part. At any point, if you think, well, I'm very comfortable with using inverse, feel free to skip forward in the video to the more interesting part or more complicated part when we are solving multi-step problems. So this is addition and subtraction. I'm just doing the opposite because the opposite of addition is subtraction. Yes? So I'm doing the opposite operation. That's working in reverse. Let's look at multiplication. Multiplication means counting in equal groups. So let's say that I have a problem of 6 groups of something. That's the missing part. I know the beginning of the problem and I know the ending. 6 groups of something equals to 42. So let's draw a model 1, 2, 3. 1, 2, 3. So that's 6 groups. That makes 42 altogether. And I know that a lot of you know the answer by now, but we're not looking at a complicated problem with huge numbers. We're just looking at the strategy. So now, because I know that 6 times something gives me the product of 42, I will have to do 42 divided by 6, and that will be the missing part. That's working in reverse. That's doing the inverse. Of course, I could count in sixes, and I can build a tower. So until I say 42, 6, 12, 18, 24, 30, 36, 42, 48, and I'm running out of space. Now I can count in sixes until I go to 42. 1, 2, 3, 4, 5, 6, 7. So 7 groups of 6 make 42 altogether. So division is the opposite of multiplication. and that will work both ways. Let's look at a very similar example. Now we're going to have a look at a slightly different case. We're still going to use the same fact of knowing that 6 times 7 is equal to 42. But if I know the dividend, and my dividend is 42, and I know that my quotient is 6, so 42 divided by something equals 6. And I know you'll think, and a lot of students find that type of problem quite challenging, because you think you should multiply 6 by 42, which isn't exactly true, because 6 times 42 would give you 252, because that's 240, add on 12, that's 252. And 42 divided by 252 does not give me 6. So what I should do is I will now work in reverse. I will divide 42 and 6, or I could record it as 42 divided by 6. Yep, and once again, I could build a tower of 6s. Sorry, I'm just going to write it quickly. It's difficult to talk and write at the same time. 6, 12, 18, 24, 30, 36, 42. And that is the type of problem that you should be dividing. You're not doing the opposite, you're just working in reverse. Yeah, that can be quite tricky, but because with the other missing box problems, we were simply using inverse. When you're dealing with a missing dividend, with a missing divisor, you should divide the dividend by the quotient. So let's go real quickly on another example. We're going to pause over here, because here it can be quite confusing. So we know the beginning of this story. So let's say that I have 156. I had 156, and I shared it between so many groups, and I ended up with 4. Now, obviously, I could build a tower until I say 156, and whether I could decide or not. But in this case, I can't do it because it's not a number fact. So what I will do, I will take 156 and I will divide it by 4. So that's 156 divided by 4. Now I can open the bus stop and I can put 156 underneath the bus stop, and that's my dividend now. 156 divided by 4. I can't fit a group of 4 into 100, so I'm going to skip that. I'm going to treat it as a 2-digit number. I can fit 3 groups of 4 into 15. That's the closest multiple, and that gives me 12. I'm going to check for the remainder, 5 take away 2 leaves me 3. 1 take away 1 leaves me with 0. 6 drops down. How many 4s goes into 36? And that is 9. 9 times 4 gives me 36. 36 take away 36 gives me 0. Sorry, I'm making those examples for you, so I'm not as fast as I could have been. So 156 divided by 39 gave me 4. Let's check if this works. So now I'm going to check it by using the inverse, because if I multiply those two, then they should give me the product of 156. So let's check. 39 times 4. 9 times 4 gives me 36. I can already see the same part over here. 0 as a placeholder. 3 times 4, that gives me 12, which happened over here. 6 add on 0 gives me 6. 3 add on 2 gives me 5. And 156. I've done it by inverse. My work is true. So now I can move on to actually a bit more complicated problems. We went through basics of inverse. Now let's look at the working in reverse problems. Now here is the almost identical problem to the one that you've seen at the end of yesterday's maths assessment and the ones that we'll be working right now with. It's the inverse problem. Though technically it's algebra. Algebra means looking for the missing part. That's literally what the name of algebra means. So I'm thinking of the number, that's our missing part. Now, how this problem is different than the previous ones is the fact that it has few more steps. So we're going to trace back those steps. Let's have a look what the wizard says. I'm thinking of a number. First, I divided my number by 2. After that, I added 98. I ended up with 100. So there was 2 steps before we ended up with an answer. What was the first step before we had our missing part? First, I divided my number by 2. So I'm going to write divided by 2. After that, I added 98. And I ended up with 100. So, like I said at the beginning, real quickly, equal sign means that both sides are equal, that both sides are the same. So if I remove something from one side and I'm removing it from the other side. So first I want to remove 98 to get closer to my missing part. So I'm going to remove 98 from here, and I'm going to subtract 98 from 100, because I need to remove it from both sides so they're equal. So 100 take away 98 will leave me with 2. So 2 is the same as my missing number divided by 2. So you see here, that's how I've used the inverse, because I've added, I had to subtract. So what I've done effectively is I've done inverse of this. Because if the wizard added 98, I want to do the opposite what the wizard does. I want to undo it step by step. So first I remove that part. 100 take away 98. Now, if the mystery number is divided by 2, I want to do what the opposite of what the wizard does. So I'm going to multiply it by 2. And it's easy as 2 times 2. My mystery number is equal to 4. Do you see what I've done? I've ended up with 100. So if the wizard added 98, I subtracted 98. If the wizard divided the number by 2, I multiplied my number by 2. And I ended up with 4. So now we're going to check it using the inverse. So 4 divided by 2 gives me 2. Yep. 2 add on 98 is undisputably 100. Therefore, the wizard was thinking of the number 4. And before we finish, let's have a look at 2 more problems. So here we have an evil monkey that is thinking of a number. So first, we've doubled the number. Then, after that, we've added 31. Finally, we subtracted 4 and we ended up with 49. So let's rewrite it as an equation. First, we had the mystery number. Then we've doubled it. After that, we added 31. Then we subtracted 4. And we've ended up with 149. So what we will want to do is work in the reverse of the evil monkey. So if the evil monkey subtracted 4, we're going to add 4 to the other side in order to remove it. So 149 add on 4. Mystery number times 2 add on 31 equals 153. You see, we've added 4 to get rid of that step, to undo it. Now, if we've added 31, we need to do the opposite. We need to remove that addition. So we're going to subtract 31. We're moving it to the other side. We're undoing that step. So we're taking away 31. So our mystery number doubled is the same as 153 take away 31, 122. Okay, so if the mystery number was doubled and it gives me 122, I need to use the opposite of doubling. So what I'm going to do is 122 divided by 2. So I need to half it. Half of 100 is 50. Half of 20 is 10. So that gives me 60. Half of 2 is 1. That's 61. I could do long division. I can't fit 2 into 1. So I'm going to treat 12 as a two-digit number. That gives me 6, 12, no remainder. So I'm trying to fit 2 into 2. One groups of 2 makes 2. 2 take away 2 gives me a 0. Therefore, I'm arriving at the conclusion that the mystery number is equal to 61. Please take the time to have a go and see if I'm correct by pausing the video and seeing if 61 times 2 add on 31 and then take away 4 will be equal to 149. If that's the case, then we're all good. And finally, what we're going to move on to now, let's have a look at the problem that we had a look in yesterday's quiz. Here we have Riddler, who's thinking of a number. So we've started at a number, and first we divided the number by 2. After that, we subtracted 12. Finally, we multiplied the number by 3, and we've ended up with 9. Okay? So, what are we going to do is we're going to work step by step with the inverse to get rid of each part. So here we have finally we multiplied the number by 3. We just need to change it into the opposite, and we're going to keep the same operation. So here we're going to have to do 9 divided by 3, which will leave me with mystery number divided by 2, take away 12, is equal to 3, because 9 divided by 3 gives me 3. Now, what I'm going to do is, if here we've subtracted 12, we need to do the opposite. We will need to add. So 3 add on 12 will get rid of that 12. We're doing the opposite of what the Riddler did. 3 add on 12 means that mystery number divided by 2 is the same as 15. So look, something divided by 2 makes 15. So now we have to undo the final step, and we need to multiply the number by 2, which is fairly straightforward. Mystery number is equal to 30. And if you got that answer, that is fantastic. Please see if 30 divided by 2, take away 12 times 3 equals 30. If you got that answer yesterday, well done. We are going to practice these problems this week. If there's anything else at all, please let me know and try out those skills in today's quiz. See you around. Stay safe.